Hi, this is Felix. Today we are going to discuss resistors in series and parallel. So now here by using Ohm's law we are trying to find the combination of effective resistance of the resistor in series connection as well as in the parallel connection. So first of all we have to consider a few resistors. Okay, so here we have to consider three resistor. Okay. So R1, R2 and R3. So these are the three resistors we are considering, and in between this combination we have to involve there is a potential. So the potential will be denoted in terms of V. Okay, so here we have considered a three resistor R1, R2 and R3. Between the series combination we have connected there is a strong potential of V, and this is nothing but a positive terminal and this is nothing but the negative terminal. Now from this potential we have drawn a current of I. So from this the amount of charge which is passes through all the three resistor is same. So therefore the flow of current through the circuit also will be the remain same, because there won't be any deviation in between the circuit. So through R1, R2, R3 the same amount of current I will be passing through. Right now, but same amount of current is passes, same potential we are applying, but here we have selected a different resistor, hence between the resistor there are different potential is developed across R1 and R2 and R3. A different potential is developed, and this will be denoted in terms of V1, V2 and V3 respectively. Now we have to try to find the total potential. So the total potential V, which is equal to, how we can able to calculate the total potential, how much we have applied, how we can able to calculate. It's very simple. We have to just take the sum of these three potential which is developed across the three resistor. So now V1, V2 plus V3. So we have to take the sum of these three value, and the sum of these three value which is numerically equal to the potential which we applied. Now here, as we know that from Ohm's law, from Ohm's law. So what is that Ohm's law? V which is equal to IR. This is the formula, and now this formula we have to apply with respect to a three resistor. Now with respect to R1, what is the potential developed across? It is nothing but V1. So V1 which is equal to I into R1, and the same way we have to calculate V2, and that is nothing but I into R2, and V3 which is equal to I into R3. So V1, V2, V3 we have calculated. Now this three value we have to apply in this above equation, so or we can say it is equation number 1. So this value we have to substitute in equation number 1. Then V which is equal to IR1 plus IR2 plus IR3. Okay, so which is equal to, in this 3 I is common, so take it outside, then remaining R1 plus R2 plus R3. So this 3 we have to write inside the bracket. So now we have to draw another one diagram. So same potential, same current which is drawn, but instead of three resistor R1, R2, R3, we have to introduce RS. Here this RS is nothing but the sum of the three resistance of the resistor value. Okay, so this is a new diagram which is equal to the previous diagram. Okay, now the we have to apply the Ohm's law with respect to this diagram. So which means V which is equal to I into RS. Now this value we have to substitute in this above equation. When you substitute in this above equation, IRS, which is equal to I R1 plus R2 plus R3. So here this I is common, so get cancel each other. So what is the remaining? RS, which is equal to R1 plus R2 plus R3. So this is nothing but the total resistance of the resistor which is involved in the series combination. So now with respect to this expression, we have to define it. The total resistance is the sum of the individual resistance. The total resistance is the sum of the individual resistance in the circuit. Thank you. Next, resistors in parallel. So the same three resistor R1, R2 and R3. So all the three will be connected parallel to each other. So parallel to each other, and in between this we have to apply the potential. The same potential will be applied between R1, R2 and R3. So here this is R1, R2, R3. So in between R1, R2, R3 we have to apply the potential of V. The same potential will be applied. Now this is the positive terminal and negative terminal. Now the amount of current, okay, so now the amount of current is derived is nothing but I, and this will be divided into a 3 through this, okay, a different amount of current will be passes, and here is I1 and I2 and this is nothing but I3. So for your better understanding, I just redraw this in another way for the better understanding. So now here R1 and R2, this is R3, and here we will have a potential, okay, right. So V positive terminal, negative terminal, then through this I amount of current is passes, and this is R1, R2 and R3. Very good. Now after reaching this point, for example A, and this is junction B. So now this I amount of current, when it is reaches the junction I, this current will be split into a 3. So here I1 and here is I2 and here is I3. But a potential will be applied between the ends of the R1, R2 and R3. So potential doesn't change, only the current is varying. Now we have to calculate the total current which is involved in this circuit. So I, which is equal to, it is derived from the potential. So I, which is equal to I1 plus I2 plus I3. So if you add this 3 current, and this is equal to this current, because this I1, I2, I3 is derived from capital I. Okay. Now by applying Ohm's formula from Ohm's law, what is that Ohm's law? V is equal to I into R. Now rearranging this, what is that I which is equal to, which implies I which is equal to V divided by R. Now this condition we have to apply in this above situation. Now what is that I1? I1 which is equal to V divided by R1, because same potential only is applied across R1, R2 and R3. So V divided by R2, I3 which is equal to V divided by R3. And now this value we have to substitute in this equation, or we can say equation number 1. So substitute in equation number 1. So therefore I, which is equal to V divided by R1 plus V divided by R2 plus V divided by R3, and here V is common, so take it outside. So V 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Okay. Now we have to replace R1, R2, R3 with the RP. So here the RP is nothing but the value of the summation of R1, R2, R3. So the equivalent value we are introducing here. So with respect to this diagram, we have to apply the Ohm's law. So by applying Ohm's law, V which is equal to I into RP. So therefore I which is equal to V divided by RP, and now this value we have to substitute here. So if you substitute, you will get V divided by RP which is equal to V 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, and here V is get cancelled. What about the remaining value? 1 divided by RP which is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So the effective resistance you will calculate. So now the sum of the reciprocal of the value of resistance of individual resistor is equal to the reciprocal of the effective resistance of the combination. Once again I repeat, the sum of the reciprocal of the values of the resistance of the individual resistor is equal to the reciprocal of the effective resistance of the combination. Thank you.